Exponent rules. Exponents are used to represent repeated multiplication. For example, x to the 5 or x to the 5th means we're multiplying x by itself 5 times. X to the 5 represents x times x times x times x times x. An exponential expression consists of a base and an exponent. The base is the number, variable, or expression that is on the ground. The exponent is the little number up in the air. This is the general form of an exponent. b to the x. b is the base, x is the exponent. X tells us how many times to multiply b by itself. For example, in the exponential expression 5 to the 4, 5 is the base and 4 is the exponent. The exponent, 4, tells us to multiply the base, 5, by itself 4 times. 5 to the 4 equals 5 times 5 times 5 times 5. This is the expanded form of 5 to the 4. We evaluate this by multiplying it out. 5 times 5 times 5 times 5. We can multiply the first two 5s to get 25, and then the second pair of 5s to get 25, and then multiply 25 times 25 to get 625. Exponents follow rules to help us simplify when exponential expressions are combined in various ways. It's important to know how to do this, as it makes a lot of our work simpler. That's why it's called simplifying. Important. Note that for some of these rules, the base must be the same. For example, the product rule. When multiplying exponential expressions that have the same base, we leave the base the same and add the exponents. b to the m times b to the n equals b to the m plus n. For example, x to the 2 times x to the 3 equals x to the 2 plus 3 equals x to the 5. Why? Let's expand them to help us see how this works. X to the 2 times x to the 3 equals x times x times x times x times x. This leaves us x multiplied by itself 5 times, or x to the 5th. You can even use numbers if you need more convincing. 2 to the 3 times 2 to the 5. 2 to the 3 is 2 times 2 times 2, and we're multiplying that by 2 to the 5, which is 2 times 2 times 2 times 2 times 2. 2 multiplied by itself 3 times is 8, and 2 multiplied by itself 5 times is 32. 8 times 32 is 256. If we apply the product rule, we would have 2 to the 3 times 2 to the 5. Notice it has the same base, and we add the exponents to get 2 to the 8, and if we evaluated 2 to the 8 in a calculator, we would get 256, the same thing we got before. The quotient rule. When dividing exponential expressions that have the same base, we leave the base the same and subtract the exponents. b to the m divided by b to the n equals b to the m minus n. Notice that this is one of the rules that requires the same base. For example, b to the 5 divided by b to the 3 equals b to the 5 minus 3, which equals b to the 2. Why? It helps if we expand these. b to the 5 is b times b times b times b times b, and b to the 3 is b times b times b. We have 5 b's on the top and 3 b's on the bottom. We can divide out those 3 pairs of matching b's in the numerator and the denominator, and we are left with b times b, which is b squared. The power rule. When raising an exponential expression to another power, we leave the base the same and multiply the exponents. b to the m to the n is equal to b to the m times n. For example, b to the 3 to the 4 is b to the 3 times 4, which is b to the 12. Why? Think of this as b to the 3rd to the 4th is equal to b to the 3 multiplied by itself 4 times. B to the 3 times b to the 3 times b to the 3 times b to the 3. We can then expand each of these b to the 3's to be b times b times b. How many b's do we have here? 12. So this is b to the 12. Raising a product to a power. Sometimes we have a product or something that is being multiplied inside parentheses with an exponent following it. When this happens, the exponent is applied to each factor within the parentheses. So if we had something like a times b times c in parentheses raised to the x power, we would just raise each of those factors to the x. The quantity a, b, c to the x equals a to the x times b to the x times c to the x. Raising a quotient to a power. The same thing happens when we have a quotient, or something that is being divided inside parentheses with an exponent following it. The exponent is applied to each factor of the numerator and denominator within the parentheses. So if we had a over b inside parentheses raised to the x power, we would apply that exponent to both a and b to get a to the x over b to the x.